group the numbers. Um, Actually, I like the puzzle version of this problem. It's called the Polish national flag problem. Essentially, the flag of Poland, which has only two colors here, red and white, uh, is given to you, but all the colors are garbled, right? So imagine being given an array with a bunch of red and white values. Can't show the whites explicitly here, but the remaining values are white. And so what you need to do is to rearrange the numbers in this array, or the colors in this array, so that you have white on the left and all the red values on the right. Right, so that's the Polish national flag problem. Uh, so this problem is essentially that instead of white and red colors, you're given even and odd numbers. And you need to rearrange the numbers so that all the evens appear on the left and all the odds appear on the right side. So evens here, even numbers here, and all the odd numbers here. That's the task. And you need to do it in a way that, um, have they mentioned it here? Okay, they haven't mentioned it here, but yeah, they have actually, the last line. You need to do it in linear time without using auxiliary space, which means you can't use auxiliary space whose size is proportional or a function of the input size. You can always use a few variables. Nobody would ever complain about that, but you can't use auxiliary space the way we were using in merge sort. So that's the requirement. Single pass. Okay, single pass is not mentioned here. It's not mentioned. Let's add that also as a condition. Single pass, linear time, no auxiliary space. That's the task. So if you think back to your sorting class, I'm sure your instructor would have mentioned the Dutch national flag problem in the context of an issue that quicksort runs into when there are lots of duplicate elements. Essentially, the partitioning becomes very skewed at that point, and so uh, this problem is actually a simpler version of the Dutch national flag problem. It's the Polish national flag because there are only two colors here, not three colors. So how do we arrange things in this way? So since it's linear time, we can't sort with all the evens appearing on the left and odds appearing on the right. That would take n log n time. Even if we were to write a customized sort function. So we need to do it in a single pass. And so we are going to take inspiration from Lomuto's partitioning, but let me actually describe it in a decrease and conquer way. So you may or may not remember Lomuto's partitioning, but even if you don't, that's okay. Let's just purely approach it in a decrease and conquer way, which means when I'm given this problem of size n to solve, what I'm going to do as a lazy manager is to ignore the rightmost number and hire a subordinate under me to take the prefix of the array size n minus 1 and to sort that, right, to rearrange the numbers there in a way that everything on the left is white or even and everything on the right is red or odd. So let's say my subordinate comes back and tells me that this is already solved for the array of size n minus 1. The question is, what can I do as the lazy manager to extend the solution to a solution of size n? Now the rightmost element here could be even or it could be odd. Or in terms of colors, it could be a red or it could be white. If it's red, then there's nothing for me to do because then it just means I have extended the red region and I'm done. But if it's not red, if it's white, then I need to make sure that I can arrange these elements, adjust these elements so that the white region is contiguous on the left and the red region is contiguous on the right. So if I know where the white region ends, let's say I have a white pointer here, uh, I can do what you might recall in the Lomuto's partitioning technique. I could swap this white number with the leftmost red number. And by doing so, I would send the white number to the left so that it extends the white region here. And this red number would come here, and the result would be something like this. Oops. Uh, it doesn't matter whether the white and red regions are internally sorted. All that needs to happen is that all the evens or the whites should be on the left and all the reds or odds should be on the right. Doesn't matter what their relative order is. So that's something we can achieve using a decrease and conquer approach. Okay, so when my subordinate is given the problem size n minus 1 to solve, he or she would have in turn hired someone under them to solve the problem size n minus 2, the subproblem of size n minus 2, and so on, all the way down to a leaf level node, leaf level worker who would have started with maybe a single element, right, which would be either painted completely white or completely red. That's the trivial case. But then each manager up in the hierarchy would be doing some work at the end, right? Notice that I am doing some work at the end after my subordinate has already painted the region of the array left to me, I mean to my left. And so what each manager is doing up this chain is, uh, let's say this leaf level manager just focused on the leftmost number, right? Because the subproblem that was handed down at the leaf level was a subproblem of size 1. Um, their immediate manager would have worked on looking at the number at index 1 and then making sure the regions were readjusted. Their manager would have worked with one more number, right? The number at index 2 and then adjusted things so that the regions are painted in the desired way, and so on. Until I, as the root manager, focused on index n minus 1, the number at index n minus 1, and I extended the previous solution constructed by my subordinate to the uh, overall solution. So this entire uh, chain of work from bottom to top can be simulated by a for loop, right? For I varying from 0 to n minus 1, right? I can write this iteratively, and the body of the for loop would be essentially the work done by the manager, work to be done by the manager who is focused on index I, or the number or the color at index I. Right? So that's how we'll write the code for this. Um, we'll just write it directly as a for loop 0 to n minus 1, where n is, let's see, what was the array here? Um, ARR again. N is nothing but the length of ARR. Okay. Now, what is the work to be done to incorporate ARR of I, right, the ith element, into the painted region? Would it be possible, folks, to mute yourself if you're not speaking? Ajay, Sayed, Mojgan. Thank you. So, what is the work that I'm doing? Well, I just explained that I'm just checking what the value of this number is, or the color of this element is. And if the color is not what it's supposed to be, it's not red, it's white, then I do a swap, assuming that I have a white pointer at at the rightmost white number, right? So I'll just look at the number that I'm doing, that I'm responsible for, the only number that I'm focused on, which is ARR of I. And if it is white, or in terms of the even or odd requirement, if it's even, right, that means ARR I mod 2 is equal to 0, right? If it's even, or you can say white in terms of color, um, what do I do? I increment the white pointer, and then I swap the white value, which is actually the leftmost red number, with my number. Right now, what is this white value initialized to? Well, when I is 0, when the leaf level worker is focused on the number I equal to 0, there is no white or red region to its left. So if we always have this invariant that the white pointer points to the rightmost white number, the white pointer should start out at -1, because there is no white number to start with. So it lies outside, just outside the whole array. So that's it. This should paint the whole array. I'm not sure if we have to return. Do we have to return? Yeah, we have to return the same integer array. So we return that array at the end. So that's the uh, code. Okay, now I have the code written here in terms of the orange and green pointers, because um, that's what I had in the sorting live class and the foundation videos, but I've written it here in terms of the um, Polish national flag problem. Any questions on this? Sudeep?
Uh, yeah, Omkar, I have one follow-up question. This says order doesn't matter,
Hmm.
but if we have to tweak the problem and say we don't need to sort it, but the relative order has to be maintained, can we still solve that in linear time,
No, then you'll need something stable, and then, um, well, linear time might still be possible,
but not
but
single
you're not in a
pass?
single pass, right? You'll figure out, you can do one pass to figure out what the size of the white and red regions are, and use auxiliary space to just like create. If I know that 40% of the elements are white, 60% are red, I use an auxiliary. I can create an auxiliary array with the same size as the original array, and I know that 40% of the numbers are white, so I can just go through them in a left to right order and keep appending them here. And then I know the remaining 60% are going to go here, and I just append them in the same order that I find them in the original array. So that's linear time. It uses auxiliary space though.
Space, okay. But what if we consider horse partitioning? So will that also not help?
I'm going to come to back to horse partitioning once I'm done with the next problem. Right?
Okay, okay,
Yeah.
sure.
So let me do both this problem and the next problem using Lomuto's partitioning, and I prefer Lomuto's partitioning, and you'll see why when we do horse partitioning. Uh, so
Okay, thank you.
let's see, any other questions, Abhishek?
Could you please explain the code with a small example of array of numbers? I'm getting a little
Sure.
confused.
Um, I mean, a general tip I would give is when you work with specific numbers, uh, so I somehow find it odd to work with specific numbers because, like, I feel that these, at least I don't come up with solutions by looking at specific numbers. S- because in the abstract, your solution should work no matter what the numbers are. But yeah, why don't you pick some numbers?
Yeah, yeah, like 4,
Hmm.
2, and 179.
Just five?
Yeah, that's fine. Like I just want to once understand like how this
Okay.
everything works.
So the white pointer starts out here, right? So the first manager, the leaf worker, is going to look at um, 4. 4 is even,
Yeah.
right? So it needs to go into the region on the left. So it'll call the white. So the white pointer will take a step forward, and the two numbers will swap. Obviously, that's not going to change anything because you're just swapping 4 with itself,
Okay.
right?
Oh,
If it's
okay.
even, the white pointer steps forward, and we swap the two numbers. So at that stage, this 4 would be white, right? And the white pointer would be here. Next, I will look at the number 2. 2 is also white. So the white pointer will again step forward, and the two values will again swap, which again doesn't change anything.
Mm.
So we have 4 and 2. This is the white region. There is no red region so far. White pointer points to the rightmost white region. 179. The next manager looks at the rightmost element of his or her subproblem, which is 1. 1 is red. So if it's red, well and good, there's nothing to be done. Right? Notice we don't do anything if it's red because we just assume we are extend. There is the the region on the right is the red region. So when we find a
Yeah.
number on the right, it's like just extending the red region by one more number. Then we move over here. Let me do it here. So why two numbers here, 4 and 2, the red region here. 7. So when I looks at the number 7, 7 is odd. It's like a red region, so we'll color that red again. Again, we're not doing anything explicit. Just move on. So it turns out that the array you constructed was already had the even elements on the left and the odd elements on the right. So when I looks at 9, again it's red, so we'll just there's nothing to be done
What
essentially.
if the 9 was an 8, let's say?
So if that was an 8, um, let's say this was an 8, so that means it's white in color. So the white pointer, which is pointing to the rightmost white number here, the white pointer will step forward, and these two numbers will swap. So we get 4, 2, and 8 making up the white region. And then we had 1 and 7 here, right? This red number was a 1, this one was a 7. So 1 and 8 are getting swapped, so that means we would have 7 here and then 1 there. Right? 1 would take the position of 8, 8 has taken the position of 1. So this is the red region, this is the white region. So the white pointer ends up at the rightmost white number, or I pointer, which you can think of as the red pointer, but it's think of it as I if you like. It ends up at the right end. Make sense?
Yeah.
Shankar?
Thank you.
Here
Omkar,
about the
here,
sorting.
in this case, the stability is not maintained. The one is out of order, isn't it?
Yeah. Stability is not maintained. Yeah.
Just wanted to.
Quicksort is not stable anyway.
Oh,
But
okay.
yeah.
I see. Thank you.
Sileni?
I'm okay. I just
Okay.
didn't lower my hand. Sorry.
Sure. Abhishek?
Sorry, I didn't lower my hand. Sorry.
Okay, that's fine. So looks like, okay, last question. Uday?
Yeah, hi, Omkar. Are you able to hear me?
Yeah.
Yeah, so the same problem, if you go back to the example, right? So we got 42871. If say extension to this, if they want to sort it, so then can we use the merge sort and sort it so that time complexity will be out of n log n?
Well, if you had to sort it, then you might as well have sorted at the very beginning, right? Could have just written a custom comparator function so that which treats all the evens as less than all the odds.
Okay.
So that way you could have, I mean, if you're going to be spending n log n time, might as well just sort the whole thing
Sort it at the beginning. Oh, okay. Yeah, thank you.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today